Are you struggling to store aggregates in a NoSQL database like MongoDB? You're not alone. Today, we're diving into how to effectively persist domain objects without mixing in persistence details. I totally get it. The idea of mixing domain logic with persistence details can feel like a recipe for disaster. Many developers face this challenge, and it's important to find a clean solution. Here's the specific question we're addressing today. One user asked, how can we persist domain objects in MongoDB without using annotations or risking data corruption? If this sounds familiar, stick around as we explore some effective strategies. So what's the issue here? When you serialize domain objects directly into MongoDB, you risk intertwining your domain layer with persistence concerns. This can lead to data corruption if your domain model changes in the future. And don't go anywhere. I'll share a powerful solution at the end that will help you maintain a clean separation between your domain and persistence layers. To begin addressing the user's concern, we will create data transfer objects, or DTOs, to separate the domain objects from the persistence layer. This helps maintain a clean architecture. Next, the user should define the structure of the DTOs. These DTOs will mirror the domain objects, but will not include any persistence-related annotations. Now the user needs to implement a mapping layer. This layer will convert domain objects to DTOs and vice versa. This ensures that changes in the domain do not affect the persisted data directly. After setting up the mapping layer, the user should implement the repository pattern. This pattern will handle the actual database operations while using the DTOs for data transfer. Finally, the user should test the entire flow to ensure that the mapping and persistence work as expected. This can be done by creating test cases for the repository methods. Fun fact, the concept of DTOs was popularized in the early 2000s, and they have since become a staple in software architecture. Who knew a simple object could make such a big difference? Now, let's look at the answers provided by other users. One alternative approach suggests keeping your domain models separate from persistence concerns. This user recommends using data transfer objects, or DTOs, which they refer to as data models. These data models will map to your domain models before saving to the database. For read-only operations, you can skip this mapping to avoid loading the entire object graph, which is a common practice in CQRS architecture. That's all for that response. Let's see what someone else had to say. One alternative approach is to define your business objects with state objects and repository functions as interfaces. This allows you to inject actual state objects into your business objects through the constructor, maintaining independence from the repository. This method offers advantages like specific business objects and strong typing for aggregates. The user also mentions using this pattern in Angular projects, where DTOs are injected as state objects, ensuring clean and maintainable code. The user notes that while MongoDB supports clean repository implementations, they are still working on a solution for managing state objects in child collections. Let's take a look at another answer from another user. One alternative approach is to store your domain objects directly in document databases like MongoDB. Von Vernon discusses this in his article about using JSON-B storage in PostgreSQL. However, be cautious of potential pollution from BSON attributes in your aggregates. To mitigate this, you can use convention configuration for serialization. Another option is to create a separate state object within your aggregate root. This state object represents the aggregate's state and can be immutable, producing new states when changes are needed. In this setup, persistence focuses solely on the state object. However, if you want to avoid MongoDB attributes in your state object, ensure that the persistent structure mirrors the state object for a one-to-one mapping. That's it for that answer. Let's take a look at another one. An alternative approach suggests using MongoDB as a good choice for persisting DDD models. The user confirms that MongoDB can serve as an event store and can be used without event sourcing by employing an object document mapper. Each aggregate instance can be stored as a document, including nested entities and value objects. To avoid mixing domain layers with persistence information, the user recommends using XML mapping instead of annotations in domain objects. This keeps the domain clean and separate from persistence concerns. To address concerns about corrupting persisted data when changing domain objects, the user suggests using custom migration scripts. If event sourcing is used, they recommend implementing event versioning strategies. Finally, the user challenges the conclusion about needing DTOs for translating between domain objects and persisted data. They argue that if you use CQRS, read models are sufficient, eliminating the need for DTOs. Here's the key takeaway. By using DTOs and a mapping layer, you can keep your domain model clean and avoid future data corruption. This approach not only simplifies your architecture, but also enhances maintainability. And there you have it. You now have a solid strategy for persisting aggregates in NoSQL databases without compromising your domain layer. If you found this video helpful, please subscribe for more insights and tips.